Yes, good evening, doctor. I am by the names of Bianca Joshua Aaron, and for this task, we were required to use paraview software to visualize data. And for this task, I decided to use MIR and CT scan images. Here we shall be exploring human anatomy using 3D medical imaging. So, the context of this analysis is basically to understand how scientific visualization works by exploring some of the techniques used such as volume rendering, slicing, isosurfacing, and clipping to extract meaningful insights from MIRCT datasets. So without further ado, let's go to the paraview software. So here I import my dataset, which is so I have two datasets. One I'll be using is the head VHT file, which is the brain, the head's VTI file, and then the brain VTK file. So for the first analysis, we are going to do where we are going to understand volume rendering, slicing, and ray trace rendering. So we are going to find out what these really mean and what is their importance. So basically, volume rendering enables visualization of volumetric data by simulating light interactions, providing intuitive depth perception and internal structure analysis. So we shall begin by importing our dataset. So here by default, once you import your dataset in paraview, it will appear like this. So to be able to view it, you have to click apply. So by default, it will give you the outline of the dataset. So to be able to do volume rendering, we shall have to change the representation from outline to volume. And then once we click yes, we are able to see our data set. So this is the brain, basically how the brain looks like. So that was basically volume rendering. So the next task is we are going to look at slicing, some of the techniques used. And slicing basically reveals cross-sectional views of datasets, allowing precise inspection of internal layers without obscuring surrounding data. So this technique is normally used in the medical field to basically understand how internal organs are organized within, for example, since here we are dealing with the human head, we just want to see how like some of these internal organs are organized and how they look like. So to do that, we'll just apply a filter called slice, which is this one here. So the moment you click here, it will bring this icon here, which will show the slice, and normally by default it's centered in the middle here. So if I click apply, it will apply the slice, and to be able to see that slice, the cross section of this data set, we just need to hide the original data set. And if we are to tilt this, we are able to see we are able to see our slice. So basically now you can see that this is the skull and this is the brain and all its composition. So some of these insights are normally used to understand human anatomy. So the next technique we are going to look at is called ray trace rendering. This one basically enhances quality with accurate shadows and reflections, critical for high fidelity presentations and publications. What we mean by this, for example, it helps, yeah, basing on this context we are going to look at, it's going to help us create basically an X-ray like image where we are going to be able to see the internal structures and organs within a human skull. So to do that, I will just allow me disconnect and open paraview again for this undertaking. So I'll just open back to my brain, um, apply as we did, change the presentation to representation to volume, uh, just change it, maybe I want it to appear like this. And now to do that we'll use some parameters. You're going to flip some parameters like the scalar opacity unit, scalar opacity unit. You can keep on playing with this to get something you are comfortable with. This I'll set to 70, and then I will also change the render the render passes to another value like before you do that you have to enable use tone mapping, and then I'll select here 5.9. So when I select this, you can clearly see it gives us an X-ray like image where we are able to see the skull and how the brain uh, settles in within the skull. We are able to see the internal organs of this human skull. So that's it for volume rendering, slicing, and ray trace rendering. So let's look at some other techniques that are used in scientific visualization, like contour filters. Like these ones basically help us to get specific values by simplifying complex data into interpretable boundaries. So for this task, we are going to use another data set. Allow me disconnect from paraview and then load another data set, which is the head. So for this, to do this, for example, we will need to, of course, first apply, and then we shall not do like how we did for the first data set. What we are going to do here is basically go, since we are interested in filters, and for this task I'm going to use the contour filter, which is going to help me get those details I'm interested in. So once I click apply, we shall be able to see the human skull. So this is the human skull, how it looks like. So in case you want to view it from the X direction, you can always come and use some of these options so that you get the desired projection of the skull or of the data. Now that is basically using a contour filter. We are able to see now, right now we are just more interested in the human skull. Now, for example, now let's say we want to understand how ISO surfaces are used. So these ones basically generate surfaces at constant scalar values. For example, organ boundaries in medical data, enabling topology analysis of critical thresholds. So, for example, you wanted to add like the human skin, like the skin on this skull. You want to see how it settles on this skull. So what we can do for this is use ISO surfaces, and how you do that, you can always come here. This is where you can this search bar and look for ISO surfaces. You can see here it has already the application has already selected for me what I want. For example, here I'll say maybe I want to add an ISO surface of 1200 and also an ISO surface of 600. So when I click apply, you can clearly see now it has added the skin layer to the skull, and you can see how the that plays out. You're able to see how the morphology of a human being is composed. You can clearly see the skin sits gently on the skull properly. So yeah, so some of the things can be used for understanding human anatomy. So so basically that's it for isosurfaces. And the other thing I wanted to look at was let's say you can use for example, in case you're interested in changing color, you can always come to view and then add the color map editor. For this, I'm not going to, for example, if you want to do enable opacity mapping for surfaces where you want to see how this settles, this skin settles on the skull, you can always come and let's see if we enable opacity mapping for surfaces, you can see the skin goes off and will remain with the skull. Now, for example, if you wanted to see how the skin keeps on building on this skull, we can always enable opacity mapping for surfaces, and then you come this point, you start dragging. This will give you the impression of how the entire out, outer layer of the skin comes into play with the skull, so that it brings out something like this. You can see how the skin kindly gently sits on the skull, and you're able to see the internal skeleton of this human being here. So that is uh, the use of enabling opacity mapping. So the last technique I wanted to go through today is clipping. And clipping basically means trimming datasets along planes or boxes to isolate regions of interest. Um, for example, in this analysis, clipping will enable us to see the bones from the inside. So to do that, you can always come here, select a clip, and once you select a clip, it will slice the dataset just like how the slice was working, but here we are basically we want to see how the inside, how the bones are organized from the inside of a human skull. So to see that, I can close some of these and enable the clip. So this is how the clip looks like. So this one can give you a cross section of understanding how the different bones and the structure of this head play along. So in a nutshell, this kind of analysis explores key techniques such as volume rendering, slicing, isosurfacing, and clipping to construct meaningful insights from MIR and CT datasets using paraview. Thank you, Doctor. Uh, that's it from me.